Okay. So Srishti, we couldn't discuss this problem in the last class. I'll solve this now and send you the recordings. So the question is, show that the ratio of the sum of the first n terms of GP to the sum of terms from n plus 1 to 2nth term is 1 upon r raised to the power n. So in this question, just a minute. In this question, there is a twist. You know what is the numerator? The numerator is the sum of the first n terms of a GP. Okay. Numerator is there, but we are not sure about the denominator. Okay. Why? Because the denominator is sum of terms from n plus 1 to nth term is 1 upon r raised to the power n. Okay. So this is denominator. So the denominator, the sum of the terms in the denominator only we are going to find. Okay. Because they're asking us to find the ratio. So you will write the red thing in the numerator and green stuffs in the denominator. All right. So we don't know what is the sum of the terms from n plus 1 to 2n because we know what is sum of first term, which is a into 1 minus r raised to the power n upon 1 minus r. So this is the formula. We are already aware of it. And first n terms. So you can also substitute the value of a as 1 here. So which will be 1 minus r raised to the power n upon 1 minus r. So this is the result for the numerator. Okay, we are done with the numerator. So let's look at the denominator. Sum of terms from n plus 1 to s suffix 2n. What does it mean? It means, assume you have a series like this, like 1, 2, 3, and so on up to n. And you will have n plus 1 and so on up to 2n. Okay. So you need to know what is sum of terms from here to here. Okay. So you have to add all the terms starting from n plus 1 to 2n, right? You're going to add all the terms in between this, but we are not sure what are all those. Okay. That is okay. You don't have to, you don't need to know all the terms in between because we know the formula. If you know the initial terms, common difference, and the number of terms, that is sufficient for finding the sum of the terms, right? So, excuse me. So we need this. The one which I circled in the black one is the sum of the terms from n plus 1 to sum of the terms 2n. Okay. So how can you find out that? So that you can find from the total series minus this series. Okay. So you take the total series. The total series is from 1 to 2n. The series starts from 1 and it ends with 2n. Okay. So the initial element is 1 and the final element is 2n. Okay. So you just write that as the first part. Okay. You are going to subtract this. If you subtract this part from the total, you would be getting this as the result, isn't it? I need just one part. Okay, I just need to find the sum of one part. Means what can I do? I can subtract the other part of the series from the whole series. Okay, so I'm just subtracting the other part from the whole series. So I'm going to subtract these. Okay, from 1 to n. From 1 to n. If I do that, I will be getting my result as sum of n plus 1 to sum of 2n. This is also like this one. Okay. So this is also sum of the series. Like you would be having plus in between. That is the only difference. Okay. So you know what is this sum of the series from 1 to 2n means. What is the formula? So the formula is a into 1 minus r power 2n upon 1 minus r. Okay. Minus 1 to n means it's a into 1 minus r power n because n is the last element upon 1 minus r. So we know it starts with 1. So you can substitute the initial value as 1 here. Since 1 is in multiplication, you don't have to specify that exclusively. You can erase that A because A is 1 here. Okay. So this is the result for this. So now we are going to do subtraction. You know how to subtract a fraction. You have same denominator. Both the fractions of the denominators are same. So you can keep the 1 minus r in the denominator, and in the numerator 1 minus r power 2n minus 1 minus r power n. This is the numerator. Okay. So you just have to take the minus inside of the second part and multiply with that. Okay, what happens? You will be having 1 minus r power 2n minus 1 and plus r raised to the power n. Okay, I'm just taking the minus inside and multiplying. All right. So this positive one and negative one will get cancelled. Okay, they will get cancelled out each other. So it will be left with r power n minus r power 2n upon 1 minus r. I'm just swapping their position, nothing much. They are in addition only, so I am allowed to do the swapping. Okay. So I do have r raised to the power n minus r power 2n upon 1 minus r as the result of the second part of the question. What is the second part? Sum of terms from n plus 1 to 2n. So that is r raised to the power n minus r power 2n and 1 minus r. Okay. I hope it is clear. So the second part, we just found the second part. Please go backward if you don't understand. If you missed out something, you please rewind it and watch it. Okay. So this is the answer for the second part. All right. So it's r raised to the power n minus r raised to the power 2n upon 1 minus r. Right. This is the result for sum of the terms from n plus 1 to 2n. Okay. So what is the numerator? Numerator we already know, which is 1 minus r raised to the power n upon 1 minus r. Okay. So you are just writing the ratio now. You can cancel out this 1 minus r and this 1 minus r. So you will be having 1 minus r raised to the power n upon r raised to the power n minus r power 2n. And I'm going to rewrite r raised to the power 2n as r power n into r power n. Because r power 2n means it is r power n plus n, right? So I hope you remember the power rule. In the power rule, r power n plus n can be written as r power n times r power n. Okay. I'm just using the basic power rule here. So I'm going to write my denominator r power 2n as r power n into r power n. Okay. So now I want you to take the r power n outside of the denominator. What happens? The numerator stays the same. You take the r power n outside, you'll be having 1 minus r power n. Okay, I have taken r power n outside. So you'll be having like this. So this 1 minus r raised to the power n and this 1 minus r raised to the power n will cancel out each other. So you'll be left with 1 upon r raised to the power n. So from that, it is proven. Okay, I hope it is clear. See.